Hi there, my name is Lars Sørensen. We're over at CVC 2019 in Las Vegas. And here at the Computer Vision Conference, we're talking to a lot of our submitters of papers, professors, doctors, keynote speakers. We'll have them all out for you here, creating these small bits of video just to give you a hint of the exciting stuff that's going on here. Next up is Dr. John Jeffrey from Elmhurst College.
Yes.
And we're going to talk a little bit about the research, the specific research that you've done, and also we'd like to understand a little bit about your normal work. But first off, what brought you to the conference?
Well, I teach at a small liberal arts college outside of Chicago, Elmhurst College, as you mentioned, and we're mainly undergrad students, but I work in, my main area is programming language theory. I've been doing a lot of work in concurrency theory lately, and in parallel languages and environments and frameworks. And I've done work over the past few summers with students in these areas, both distributed architectures and shared memory architectures and things like that. Well, I was looking for more applications for doing some work and testing ideas in new programming language constructs, libraries, and so on. And so some students were interested in robotics, some were in computer vision, some were in parallel systems. So I thought, how can I combine all of this? So I wanted to take, say, pictures, aerial pictures of a environment in which there's obstacles, and have a robot get information from the pictures and be able to have an algorithm that plans a path around the obstacles. So this was where the computer vision came in. I have a student who is presenting with me. He did the bulk of the work in terms of coming up with a pipeline of algorithms that are out there, but he tweaked them a bit and had some really nice results, so he sent it in and his paper is accepted here. So I'm working with him on now taking the results of creating a path through a graph, translating that into robot instructions through some of the languages that I'm working on, and then we're going to go back and investigate his algorithms and see if we can use some existing parallel algorithms for, for example, k-means is used in there, and so we're going to be looking at some, in implementing this on probably some NVIDIA clusters and things like that.
Awesome. So that's like a broad perspective you had for attending our conference here. And is it offering these connections already, or is inspiration also for your student? Like, are you getting the info or the questions that you've hoped for?
Yes. Oh yeah. And just getting to talk with the other participants here has been tremendous. And we present in later today, and we are going to hopefully get some insights and more information from some of the people in the audience. But I'm really excited to see this. We've got students working on the robotics side, so we're going to fully connect this. That's sort of in the future, near future.
Yeah. So obviously your experience is in a much wider perspective. Could you tell us just a little bit of the exciting things that you've been working on?
Well, one of the things is that I'm looking at models of all different languages, from logic languages, functional languages, and taking in, I'm looking at models. I've used in the past PetriNet models, high-level PetriNet models, for extracting the parallelism, trying to do automatic extraction of parallelism in languages. There's a lot of work in that area, but I'm trying to go back into the PetriNet theory and look at some of the underlying linear algebra that can extract some information out of that. And so those are the kinds of things that we're looking at in the big, so as you can see, I'm trying to bridge several different aspects of student work together.
Yeah, that's awesome. And then if we're connecting this to like the research that your student will be presenting, or you co-presenting?
Co-present. I'll do the intro, and he's going to present the bulk of it.
Yeah. So that focuses more down on a specific part.
Right.
You reveal, we won't tell anyone, reveal some of the surprising elements maybe that came out of the findings.
Well, it was it was sort of ambitious after listening to some of the talks here, in the sense that it was taking just about any scene, whether it's from satellite images or aerial photographs, or just a camera above on a ceiling down, and very difficult, like park images, pictures of parks, or just pots and pans on a floor. We were experimenting, and he got some really nice results, just taking and tweaking parameters of some existing algorithms, but he pipelined them in a nice way, and so that was nice, nice work, and apparently the reviewers thought it was nice too.
Yeah. So, and just in your opinion, as you're from your position, and already, like, this is the sense that I get, are a connector of all these different fields. So what do you think is the biggest profit yet to gain if we start making these new smart connections?
Well, I think in terms of our work, I think that it could be used for, in a warehouse, for example, have a camera located in the ceiling, and it would be in a static environment, that the drone or the camera up on the top would send the information down to the robot. It would run our pipeline of identifying obstacles and send down the path from point A to point B. The robot would then process the path into the instructions and then go through that. Now, we could do it and reevaluate every delta t and turn it into a more dynamic environment. That's where I would like to see this go.
And that, wouldn't you think that maybe in even further future that we would have the systems evolved such in a way that they would just have enough censoring or understanding of the input that they're getting from their direct surroundings to orientate on that, and they wouldn't need like an extra step, like an external image.
Exactly, yeah, and they could just, getting from the points, that's another aspect of just with automated vehicles in general. But I was thinking just having a top picture, and then creating the path, rather than reevaluating all the points and needing sensors, and I thought this was a very simple way for students to understand and get to use put together these algorithms. But I think it's would be a real efficient way, to just to be able to find this path through. What you're proposing, I think, is just going more real time and adjusting in a more dynamic environment, and that would be future work, definitely.
Yeah. Awesome. Well, we're seeing a lot of research being presented that is like a predecessor, or for what's yet to come.
Exactly.
So I just to round it up a little bit, anything particular that you would be interested to connect to, because we're reaching out with these videos to a lot of people and trying to make new connections also. So what would be interesting connections?
I would like to hear what people have done in terms of parallel systems for these, for what I described, where you're using for obstacle detection and just generating paths. I know that there were some talks I couldn't be, because of the parallel talks.
You can only be at one place.
So I would like to track down some of those authors and then also see if where parallelism could be placed in this.
Awesome. I want to thank you so much for making the time for being with us, Dr. John Jeffrey from the Elmhurst College. And obviously, as the doctor already mentioned, we have so many sessions going on. You'll always be missing more than you can see. This is also a reason why we create these videos for you. So if you want to see more, subscribe to our channel. We'll make them all available to you. Also, our keynotes will be published right there. And thank you so much for watching this video. Hopefully, we'll see you in the next.